Hello everyone. In this video, we will be discussing one numerical, that is a design of the bevel gear. Already in video 5, we had discussed one bevel gear problem, where in that video we couldn't able to discuss in detail in the particularly the last step, that is based on the dynamic wear and the strength we didn't discuss. So in this problem we will discuss that in detail, and the previous steps, that is in the identifying the weaker member and finding out the tangential force and checking the stresses, everything it remains same here, that we will rush up quickly, and the last step will focus more in this particular problem. And this problem I have taken from VTU prescribed textbook, Design of Machine Elements, and the author is Bandhari. So we shall move to the question given. So the question given is design a pair of bevel gears to transmit 12 kilowatts at 300 rpm of the gear and 1470 rpm of the pinion. The angle between the shaft axis is 90 degree. The pinion has 20 teeth and the material for the gear is cast steel. So the values properties is given, that is allowable stress is 183.33 and Brinell hardness number it is 320, and take service factor as 1.25 and check the gears for wear and dynamic load. Suggest suitable surface hardness for the gear pan. Okay. So a very direct question, and even compared to the previous problem, here we don't have much work because most of the data they have given in the question. So power given as 12 kilowatts, and both the speeds they have given N1 and N2. So since they have mentioned the gear and pinion speed, let me go with the gear as the second one. So that is 300 rpm N2, and the pinion value, that is N1, that is 1470 rpm. And the angle between the two shaft is given as 90 degrees, the summation, and the Z1 value they have, that is a pinion value they have given as teeth as given as 20, and service factor is 1.25, and allowable stress for the both the material they have mentioned it is 183.33. So we shall start the problem with the velocity ratio finding out. So because we need to find out the other unknown, that is Z2 and other things. So as we know, like the velocity ratio formula is I is equal to N1 by N2, which is equal to Z2 by Z1, which is equal to D2 by D1. Since N1, N2 is known and even Z1 is known, I can able to find out Z2. So first let me find out the I value, that is 4.9, equating I value to Z2 by Z1, I can able to find out Z2, that I am getting as 98. And since the right angle bevel gear it is 90 degrees, it is basically a meter gear. So first let me find it out delta 1 and delta 2 for the meter gear. So the formula is 23.409 for delta 1 and 23.410 for delta 2. So that is tan inverse 1 by I, so that is 7.535 degree, and for the delta 2 it is tan inverse of I, that is 78.465 degrees. So let me find out formative number of teeth in a straight tooth bevel gear, that is ZB is equal to Z by cos delta for both pinion and gear. So for pinion it is cos delta 1 and Z1, for the gear it is cos delta 2 and Z2. So equations I have taken from the design data handbook, that is 23.425 and 23.426. So the values I am getting for the pinion and gears are 20.442, and for the gear it is 490. And here they have not mentioned what is the angle. So I'll be going with a 20-degree full depth as usual, like the previous problem. And the Lewis form factor for the 20-degree full depth involute, it is 23.116. The formula is 0.154 minus 0.912 divided by ZB. So here I'll be finding out y1, y2 value, that is for the pinion gear I'll be finding out. So I know the ZB value, that is for the pinion and gear. By substituting the value, I am getting the y1 value, that is for the pinion as 0.1094, and for the gear it is 0.15214. So we need to identify the weaker member, that is nothing but the product of the Lewis form factor and the allowable stress value. So allowable stress value, which is given as 183.33. So 183.33 into 0.1094 and 183.33 into 0.15214. So among that, the least value will be considered as the weaker member. So as the pinion gear of the same material, so pinion is the weaker member. This is a very important point. If both the pinion and gear are made with the same thing, we need to assume pinion is the weaker member. So the design process should be based on the pinion. So first we'll start with the first step, that is the designing, where we'll be initially finding out the tangential tooth load. So the formula is Ft is equal to 9550 into 1000 into power into service factor divided by speed into R. Since we are doing for the pinion, so it is N1 R1. So service factor, which is given in the question itself, that is 1.25. So the only unknown data here is N1, sorry, R1, So R1 is nothing but pitch circle radius of pinion, that is d1 by 2. Since we do not know d1, it is m into z1. So m is nothing but the module, and I know the z1 value, so I am getting R1 value as 10 module. So I am getting tangential to thought the value after substituting everything. I am getting it is 9744.9 by module. Then moving to the next step, that is tangential to thought from Lewis equation. So that is 23.433a. So here b value is unknown and r value is unknown. So r value I will be finding out from the equation 23.421. The formula is m by 2 into square root of z1 square plus z2 square. Since both z1 and z2 is known, I am getting r value in terms of module, that is 50 module I am getting, and phase width value I will be considering r by 3. So r value I know that is 50 module and 3. So I will be getting the phase width as 16.67 module. So now I'll be going with the formula with the range which is given as r by 3, which is smaller. So from the from 23.432a, where r by 3 is equal to 16.67 module, which is greater than 10 module. So I'll be taking the phase width as 10 module, because we cannot go with more than 10 module as per the conditions. So now while substituting the phase width value and r value in the ft1 value, so I'm getting the ft1 value as 504.07 m square into kV. So now I need to equate equation 1 and equation 2, where 504.07 m square kV, which is equal to 9744.9 by m, where I am getting the equation in terms of m cube kV is 19.332. So we will be checking down by trial 1 and trial 2 method, that is the CV value we will be checking out based on the velocity value, assuming for the module 3 means I am getting it is the safer one in the very first step itself. So I'll be going with module as 3 mm. So next step would be checking for the stresses, that is allowable stresses and induced stresses I need to find out. Allowable stress is product of the static stress into the velocity factor. So the value I am getting as the safer range only I am getting, so it is satisfactory. And similarly, the strength point of view also I need to check it down by using this formula, that is Fb is equal to mb sigma by into 1 minus b by r. All the values are known, so I will be checking out, and here the value should be getting greater than the given value, then it is correct. So the dimensioning like addendum, redundum, everything we need not to worry, because from the table 23.1 all the formulas are there, we can write it down because all the values are known here. Because if you know the module value, remaining things we can write it down everything. And similarly delta 1 delta 2 also we know that, so easily we can able to find out. So we can directly moving to the last step, which we have not discussed in detail in the previous problem, that is checking. So first let me check it out, the dynamic load, that is the formula 23.468. So the formula is ft plus 2 into L into Vm into Ft plus Bc divided by 2 into L into Vm plus square root of Ft plus Bc. So here the Vm value is 4.168. If you are getting error value is 0.07. Similarly, let me go with 20 degree full depth steel combination, where I am not getting for error 0.075, C value is 870, and for 0.05 it is 580. So I'll be finding out what is the exact value for the C. So I'm getting in between the ranges 812 by the interpolation method. So I'll be substituting the value. It is 21, not 2 into L. It is 21. Sorry. So 21, by substituting the C value, I'm getting FD as 13421.436 Newton. Then the second step is endurance strength. That is F endurance is F suffix minus 1, and the formula is sigma F into B into Y into pi m, that is R minus B by R. So all these things. So while substituting this, because here everything is known, R value is known, B value is known, not in terms of modules, we know the correct values. So while substituting in this, we need to check it out, what is the value we are getting, the endurance strength value, what is the value we are getting, we need to check it out, and based on that we can write down the value. Here a value I am getting as 551.8 Newton per mm square. So ultimately, while substituting, I'll be getting okay, whether the design is satisfactory or not, I can check it out. And last step is nothing but what is that, the VS strength. So VS strength like 23.470A, we need to take it down, where the ratio factor we need to find out, and along with that limiting surface fatigue stress we need to find out, load stress factor we need to find out, then wear load we need to find out, and we need to check it out whether it is coming